Okay. So now we can define the maximum likelihood estimation in this fashion. So we want to find the value of b sub 0 through b sub q as estimates for the beta coefficients such that the overall probability of outcome y, okay, either 1 or 0 for all the observations. So this part is for just one observation. Now if you find this likelihood function for all the observations and multiply them all, so that's what that uppercase pi means. So when you multiply all of them, then we get the likelihood of all the different y's that we have in the observations. Yeah. And that function needs to be maximized. So we want to find b sub 0 through b sub q values such that this function is maximized, and that's why it is called maximum likelihood function. Okay, let's see how this is how we can set this up. Okay, so trying to estimate logit function using maximum likelihood estimation procedure. So here we have the data set. Okay, we will look at this example in Excel in a little bit. So you have all the x variables, and then we have the target variable. So this x variable is like any other situation. You have all kinds of predictors, and the y values are either 0 or 1. Right? Now you start with an initial estimate of these coefficients. So you enter some numbers. So your initial trial value. So you can probably put 1 or 0.5, 0.6, whatever. None that's arbitrary. So you put that value. Now using these coefficients and these x values, you compute the L value. Right? So once you have the L value, then you can compute e to the power of minus L. Then we can use, once you have e to the power of minus L, then we can use this formula that we saw previously and find y hat. Okay. So once you have y hat, that is p sub y, and then you can get p sub y and y value, the actual value of y, with p sub y, and set up this likelihood function. So you get p sub y to the power of that value, and then 1 minus p sub y to the power of 1 minus y. So this is the likelihood of this row. Then you copy that all the way down, so you'll have a likelihood for each observation. And when you multiply this column, you get the likelihood of the entire data set. But trying to maximize that function is mathematically very problematic. So we want a linear function. So you take logarithm, natural logarithm of this value, and then you can add them all up. So when you add all of that up, okay, so this is the, when you multiply this column, you get the overall likelihood function. But since this is trying to maximize this is problematic, so you take computationally efficient transformation and then you add them up. So our maximum likelihood problem turns out to be find the values of b sub 0 through b sub q such that this is maximized. And for that we can use a solver function in Excel, and in software platforms like SAS, they do this computation automatically. So in summary, so maximum likelihood estimation comes out to be like this. So start with initial estimates for the b's, then find L, and then find 1 over 1 plus e to the power of minus L for all the records. Then compute the likelihood for all the records. Convert the likelihoods into an ln function. Add them all up. Okay. So when you add them up, you get ln of the likelihood function. So the maximum likelihood estimation problem turns out to be find the value coefficient values for these such that this ln function is maximized. And we can do this in Excel. Now we'll look at an example using Excel solver next.